Yes, take it out. It should be done. Yeah, me trying to negotiate dinner things also at the same time. All right. The last thing we were talking about Thursday, yeah, I'm like losing days of the week, was polarity. So from polarity, the last big topic then is referred to as hybridization. So one of the things we sort of mentioned earlier in the chapter was that if you actually want a bond to form, if you want there to be one up and one down arrow in your orbital, you actually have to have some blank spots. You have to have some unpaired ones. But if you go back and you look at some of the electronic configurations for some of the more common elements, things like carbon and oxygen and hydrogen, some of them have unpaired electrons and some of them don't. So we need to have a way for us to generate the unpaired electrons and not have the molecule fall apart. The and a stable molecule is actually a pretty important part. So the hybridization is smearing or mixing a couple of orbitals together to give you some new ones. So hybridization has 5 options, at least as far as general chem is concerned. We've got 5 little designations here. We've got SP, SP2, SP3, there is no SP4, SP3D, and SP3D2. So we're going to kind of go through them, and I tried to put as many pictures as possible in the document so that you have a better idea on sort of what these look like. So think back to one of the previous chapters when we looked at the s orbitals. They're a little ball, they're round, spherical. And the p orbitals are the ones that kind of look like 2 teardrops joined at the tip. Well, what if you blend them together? You kind of mix an S with a P, and you end up with 2 orbitals that are kind of equal and opposite. If you look at the top green one, we're seeing it with the large or the lion's share part over toward the right-hand side of the axes. The one below it, also looking at the green picture there, looks identical, but it's a mirror image with the big share of your orbital over on the left-hand side. So if I were to overlap them, and I couldn't find a good picture I liked that actually showed the overlap of kind of the top one with the bottom one, but what you get is 2 equal and opposite looking hybrid orbitals. We're going to pick on beryllium. Beryllium being a metal, but being a very small metal, is one that tends to undergo sp hybridization. So first think for a moment about beryllium by itself. If you have beryllium all by its lonesome, we've got 1s2, 2s2, which is kind of a problem because that 2s2 means we have basically one up and one down arrow together in the same blank. There are no unpaired electrons, which would imply that the beryllium couldn't make a bond. But we know beryllium does bond. So in order to make it capable of bonding, you do this mixture of S and P, and you get the 2 equal and opposite ones. What if you did it with more? What if you pulled another p orbital into this situation? Remember we talked a little bit about boron being a rule breaker. Boron's perfectly happy with 3 bonds and doesn't have to have a 4th bond and doesn't have to have an octet. This is more underlying pieces to the Y. So if we take the S part, the round part, and this time instead of taking 1 p orbital, the px most likely, we're going to take a px and a py, and we're going to kind of smush it all together, and you get kind of an even more lopsided effect. Let me scroll down a little bit further here. If you look at the yellow pictures there, you see a little tiny itty bit of the yellow orbital on the opposite side of the axis. It kind of looks like it had a leak. And then you see a big portion of the orbital along the x-axis. We see one that goes along the y-axis and another one that goes along the x-axis. And if you kind of spread them apart so that they give you as much possible space as your electrons would like to have between them, this is more wise. We talked about trigonal planar as a molecule that boron likes to make in terms of geometry. This gives you more Ys, okay? Because you only have 3 blobs, okay? In this case, 3 equal and opposite blobs in yellow there of where your electrons can reside. This is what allows you to get that flat triangle architecture. Now the sp3 one, in the world of hybridization, it is the most common one. Carbon does it, silicon does it, nitrogen does it. Other atoms do it occasionally too, but those 3 in particular are kind of stereotypical for having the sp3 hybridization. If we take a look at a couple of the molecules, and I kind of dug some more stuff up here. So we've got a situation where you take the S, the round one, 3, basically all of the p orbitals, px, py, pz, squash it all together. You have those little tiny loops along the inner edge of the axis, basically where the lines of the axis cross. But you have 4 blobs that all poke out at that magic 109.5 degree differential, okay, between the legs. And this is what allows you to have tetrahedral geometry for things that have 4 legs. Now, we've seen a few rule breakers. We've seen a few that violated the octet, and not boron. Boron violates the octet in the lower end. It has less than an octet. But we've also seen a few, especially when we talked about resonance, that violated the octet in a more way. They had 10 electrons, or a max of 12. Well, definitely, if you have more than an octet, you've got to have a higher level of hybridization. So this pulls in our last 2 higher versions of hybridization. We've got sp3d and sp3d2. Sulfur likes to do this. Phosphorus likes to do it. Some of the noble gases, the lower noble gases, things like xenon, argon, krypton, not neon or helium because they are much too small. So have a look at this one, and it shows you a Tinker Toy picture there of something that is trigonal bipyramidal because it has one pointing up, one pointing down, and the three that basically are sort of orbiting around the middle there. This is sp3d hybridization. What about the final, most expansive one? So octahedral is the one that we were looking at both in lecture and in lab that has 6 legs. Remember, the octa is if you were drawing this as a 3-dimensional solid device, solid form. In fact, there are only 6 legs. But sp3d2 is what allows you to get there. So let me go back to my whiteboard because there's some stuff I want to kind of address here that, let's see if I can do the draw thing. All right, so if you have one S and one P, so one of the things this does for you is it gives you what is referred to as 2 areas. So basically, imagine that your S had a little 1 above it, and that your P had a little 1 as an upscript. So 1S and 1P gives you 2 areas, but that also means that you have SP hybridization. You can't have less than 2 areas, not in general chem anyway. If we have an S and we have 2 P's. Okay, so note this gives us 3 areas. Squash it all together, mix it up, blend them together. We end up with sp2 hybridization. Now, one of the things you need to think about is areas are sometimes a bond, and areas are also sometimes a lone pair. This is why I've been kind of introducing you to a pattern. When you're drawing these out and then you're analyzing them, kind of like the homework set, it asks you how many bonding, how many lone pairs. Well, if you add those 2 numbers together, you get a number between 2 and 6. So if I have S and 3 P's, if my fake little drawy thing was cooperating. So this gives me 4 areas. The areas then have a hybridization. Oops, I need to undo that. So S P3. Okay. Then you hit that expanded octet idea. You have 1S, 3 P's plus 1D. This will give you 5, which then ultimately leads to having sp3d hybridization, and then the max, the top end, you can't go above this in terms of general chem, is your S plus your 3P plus 2 Ds. And that will give you 6 bonding areas. So S, P, doesn't really look like a 3. D2. So keep this in mind. You are adding bonding plus non-bonding to get a number between 2 and 6. 2 and 6 being included also. So 2 is your lowest available value. 6 is your highest available value. You can have other stuff in between. You can't have 1 and you can't have 7. All right, let me go back to my other pictures here. So one of the things we haven't really looked at a whole lot is the idea, and I have kind of a, there's supposed to be 3 lines in between where there's this little gap here. I don't think I can do 3 lines on Microsoft Word. It's supposed to have a triple bond in there. And I couldn't figure out how to make it look the way it was supposed to, because obviously under more normal circumstances, I draw these on the board. I'll actually use the whiteboard here in a moment. So also I'm missing some hydrogens here. So actually, let me go back over to the whiteboard. That might be the easiest way to do this. All right. C2 H. And of course, my H is like horribly crooked there. All right, so that's the left-hand part of the molecule. Here's the right-hand part of the molecule. And this kind of looks pretty normal in that all we're seeing is single bonds. Nothing is violating octets. Nothing is violating duets. Everything is single bonds. What if you took off a couple of the hydrogens and instead put a double bond in between your carbons? So it looks more like this. And note, I kind of drew it a little bit more true to reality in that once you create the double bond in between your 2 carbons, it tends to torque the angles between your hydrogens and where the carbon is to be a little bit different than you might have otherwise expected. We're kind of veering away from the concept of the whole 109.5 tetrahedral to something that's closer to trigonal pyramidal, especially if you like took your thumb and you covered up 1/2 of the molecule there. Up, oh, phooey. It always does to me. All right, I'm going to leave it off on the spotlight for a moment because we're using the whiteboard anyway. So how about the last one? All right, and then this looks a little more like how the molecule's actually built. We've got 3 lines, hence my triple bond in the middle there. This is actually a relatively linear molecule. So all of this is kind of the starting point for going back over to my other bit here. All right. See the little squiggle that's sitting on top of the straight line there? Okay, this is known as a sigma, more fun Greek letters. If you have all regular single bonds, not only does this give you a carbon which has a relatively normal sp3 hybridization, we're also going to call the bond that happens to run between the two carbons, in addition to being a single bond, single, it is also referred to as a sigma bond because it's kind of like a little shuttle service. The two electrons that are part of that bond basically kind of drive back and forth between the nuclei of each of the carbons on either end. What if you had that double bond situation? All right, that'll give you something different. So here's another look at the whole idea of the single bond. You've got two carbons, each is sp3 hybridized, and you snuggle them up close and you get a little overlap so that like the blunt end of the two balloons there start kind of overlapping, merging. And you get this giant one single oval blob that represents the electron density, the electron cloud that is between the two carbons. So when you steal two hydrogens, one from each carbon, we get that version that has a carbon, a double bond, another carbon, and only has 4 hydrogens. One of the bonds is not a sigma. One of the bonds is referred to as a pi bond. Yes, as in like pi r squared. The description is also a little bit different. The pi bond has an electron pair, which is kind of a half and half deal. If you look at the pale blue, you'll see it says pi bond in the upper pale blue, and it also says pi bond in the lower pale blue. The purplish color that's in the center is your sigma bond. Now, being that I have taught high schoolers, both in public school and a bunch of homeschoolers too, over the years, I've had a couple of different students tell me, it looks like a hot dog on a bun. So think about it that way, okay? Your bun, hopefully, has 2 halves so that your hot dog, your sigma bond, can lay in the middle of the 2 halves of your hot dog bun. And so the same kind of mental image crops up for this. Your pi bond is kind of a half on top, half on the bottom, whereas the sigma is a straight line down the middle. But we also saw triple bonds. So you definitely have to think in 3 dimensions, and I wish I had a better set of models that would image this, but the best I can come up with is some decent pictures. If you have a triple bond, that molecule that only has 2 hydrogens, but it also has 2 carbons, so it has that triple bond in the middle. One of them is a sigma, because you always have to have the sigma, otherwise your molecule falls apart. But it has 2 pi bonds. Okay, try to visualize this as 3-dimensional, because look at the colors. So the yellow bit is down the middle. That's your sigma bond. Your pink half on top, kind of half on the bottom, is one of the pi bonds. The pale blue half kind of in the back and pale blue half on the bottom are your other pi bond, or is your other pi bond. So as you have multiple bonds, you end up with 1 pi or 2 pi bonds, depending upon whether or not you have a double bond or a triple bond. So this is kind of the tail end of the hybridization information. The idea being that you're trying to pull those last little options together, because not everything we see has single bonds. Remember all those resonance structures we at least kind of skimmed through? Some of those had some double bonds. So they have hybridization going on that involves sigmas and pi's. So let me see if I can pull up my homework assignment just so I can show you kind of what we're looking for here. And of course, I can't find it when I'm looking for it. I'm looking for my file that I can't find. Arg. Because of course I have so many different files in so many different folders. My brain is like going, okay, which one did I dump it in last time? That one, okay. All right. Back to screen share things. All right, this is basically what your homework set looks like. And somebody asked me about this in lab last night. The front page is a rehash. The front page is a reminder of a lot of the things that you need to sort of keep in mind when you are drawing Lewis structures to be able to answer these questions. So it gives you the 7 most common geometries. It gives you some of the preferred bonds, remembering that there are sometimes bonds that might violate. Some of the more common Vsepar formulas, the hybridizations, and a little bit about the polarity. It gives you kind of some tips. Here's kind of the method that you should use as you're sort of working your way through this. And so I would suspect that probably the best place is do your Lewis structure kind of off to the right-hand side here. And then it asks you, how many bonding pairs? Now keep in mind that when it asks you bonding pairs, we are talking about the center atom. So like in that first molecule, most of those questions apply to the carbon that is in the middle. How many bonding pairs? How many non-bonding? What is the hybridization? What is the Vsepar? You can use ABs or AXs. It doesn't really matter. What's the geometry? And then is the molecule polar or non-polar? So remember, sometimes you have polar bonds in a non-polar molecule if you have a really, really super symmetrical molecule. So similar to the lab assignment, there are 12 different molecules here and the same kind of information that the lab asks for also, although the homework doesn't ask you about bond angles, whereas the lab thing doesn't ask you about hybridization or polarity. So in a way, the lab assignment and the lecture assignment are supposed to kind of mesh together to give you a good feel for all of these pieces fit together. And there goes my stupid. I hate this thing. Okay, yeah, my fussy webcam. That is the end of the chapter. That is the end of the stuff for the homework set, which is due on Thursday. I will post the answer key probably in the afternoon on Thursday. Your test becomes available on Thursday night at midnight. You have Friday, Saturday, Sunday, Monday to do your fourth test. Now, we only have one more Zoom meeting, and it's no new material. It's a ask questions about things you might have pending or whatever remaining questions you have regarding the final exam. The final exam is the middle of next week. It goes live. I believe I have it set to go live at midnight on Tuesday. I'd have to go back and check that. I think it's midnight on Tuesday, and then you have until midnight on Thursday, because I have a time frame. I have to file grades by Friday evening. So I'm definitely on a deadline there. For test 4, and kind of keep this in mind, and I'll re-mention this on Thursday when we talk about the homework. The last question on test 4 involves drawing some Lewis structures. And because there are no real drawing functions on Canvas, and there's all these instructions are redone on the test itself, you need to take a sheet of paper and you need to draw that handful of Lewis structures and answer the questions that go with them, and then scan it, take a picture of it, and email it to me at tcc.edu so that I can then manually grade that final test question. I couldn't come up with any other really reasonable way because of the fact that there are no drawing functions on Canvas. So that last final question is something that you're going to have to email me some information about. The final exam is all multiple choice. I am done typing it. It is 50 multiple choice questions. I tried to be pretty equal about all of the chapters that we have covered. There's about 6 or 7 problems per chapter. All of the major concepts. There's also a bigger time window for the final exam. There's a 6-hour time window for the final exam. And since some of you have me for lab, I'm also still in the midst of grading what people are sending me for lab assignments and sending out some reminders for people that owe me things, and also slowly moving toward inserting zeros for things that I don't have yet. You can still submit them up until the 14th, up until Monday. But I'm also trying to save my sanity a little bit by not having to deal with all of the columns on the grade sheet at the same time. So I'm kind of moving in that direction. Homework due on Thursday. This is your final homework set. Next Tuesday is just Q&A stuff. There's nothing new because this is the end of the information.
Ms. Moeller?
Yes.
You sent me an email about my I think it was my pre-lab.
For some reason, when I opened it, instead of Lewis structures, I see little boxes. I don't know why it did that.
Should I have drawn those out?
Yeah, I mean, you're supposed to draw them out. I expected people to either, take a picture and PDF it or scan it and PDF it.
I didn't draw them out. That's why.
Oh, okay.
But
So go
I
back and
got
draw them out, and then just either take a picture and email it to me, or
okay.
scan it and email it to me,
I
and
got
that'll
some.
fix that problem.
I got some more stuff I got to drop off to you anyway. So I
Okay,
can
that's fine.
So I didn't know you wanted to draw that out. So
Yes, those are actually supposed to be little actual Lewis structures with lines and dots and little symbols for your
I got
for your elements.
All right, fine. I'll take care of that.
Other questions regarding lab or lecture? We are definitely heading toward the bitter end here.
When is the last homework is due?
Thursday, so 2 days from now. So that I have a chance to go over it Thursday night, 2 days from now. And that'll help you then be prepared for the test this weekend.
Okay.
There's only 12, there's only 12 molecules. It's not like there's an almighty ton. There's
So
only
it's
12
due
molecules.
by class start on Thursday?
Midnight, right?
I will probably, yeah, I'm probably gonna set it like to like 5 o'clock on Thursday then. I hadn't thought about that. I had kind of a brain freeze on that. Yeah, it's probably gonna be like 5 o'clock just because I want to be able to go over it in class, even if I haven't graded them yet. It's like, this is one of these things where some semesters, some normal semesters, I grade them in class, which always is its own set of hell. Sometimes I do something other variation. So, but because we're doing this digitally, I'm probably going to go back and set it as the due date for 5 o'clock on Thursday. Like I said, it's not a huge volume of information. It's 12 molecules and the same things that we've been talking about for about a week and a half now. So it's not a really lengthy like number crunching. It's draw the pictures, answer the little questions that go with them, which I think should be pretty straightforward.
So you want the pictures drawn on the homework too, right?
Yes.
All right. All right.
My suggestion is draw them. There's a little label that says Lewis structure that's kind of off to the right-hand side of the page. My suggestion is that's probably the best area to draw them in. That way, when you take a picture, I can see the Lewis structure and the answers to all the little blanks at the same time.
Okay.
Other questions, lecture or lab? I graded a batch of stuff that people sent me in lab yesterday, this morning. So I'm catching up on that. And like I said, I'm sending people email going, I couldn't read this, or it didn't work, or yeah, I'm trying to make sure that I give you guys notice if there's stuff I can't open.
Do you know when you get lab grades from the other teachers?
Next Tuesday morning is probable, because
Okay.
I think all of us are setting Monday, although it's possible that McHugh and Wheaton might have their turn-in dates set on Friday, but I'm pretty sure that none of us have our turn-in dates for lab set past Monday. So the usual thing is whoever has the end of the lab week, which is me, because after Labor Day, all of our labs were the last day of the lab week. Lab week went from Tuesday through till Monday after Labor Day. Usually the general trend for us is whoever has lab last, lab grades are due the next day. So sometime on Tuesday, I have to give people I don't have for lecture, I have to give those lab grades to the other people, and then the other people are supposed to be giving me their lab grades probably Tuesday afternoon, Tuesday noonish is my best guess.
And the final will be 15th, right?
Yeah, you have basically about 48 hours to do the final exam. I think I have it set to stop at midnight on Thursday. I think that's the 15th.
Thursday is 17th.
Oh no, okay. No, so The final exam you have until Thursday, a week from this Thursday.
Okay.
It's not active yet, though. It won't go live yet. It won't go live until the other one shuts down because I'm trying not to overwhelm people with trying to do 2 things at the same time. You have fewer days, but you have more hours on the day that you do it to do the final exam. You have 6 hours instead of the usual 4. Because there's a little bit more questions. There's 50 questions. So I decided that 6 hours was more reasonable for that.
Will the final exam also have drawing like the Lewis structures? I know we're worried about that for the final test.
Okay, no, they're all multiple choice. Any
Okay.
Lewis structures you see on the final exam will be choose the one that's correct kind of thing.
Okay.
Because I decided doing any drawing on the final exam would make it that much harder for me to meet my deadline. So there's drawing on test 4, but there is nothing but multiple choice stuff on the final. 50 multiple choice questions, 2 points apiece.
And test
Lots of them are similar to previous test questions. They're not identical, but they're similar.
and test 4 is 7 and 8, right?
6, 7, and 8. Okay,
Okay.
because it's quantum. We did all of chapter 7, but we only did one section of chapter 8.
Okay.
Hybridization is the only thing we did out of chapter 8. So it's just one section. It's like 2 and a smidge chapters. So little tiny bit more than the previous test, but not much. After test 4 is done, then I will go back and tell Canvas to do the drop the lowest grade thing, but I need to have 4 test grades in the system before I can tell it to do that. So there will be some more changes next week as I'm crunching all the grades. Anybody who's taking 112 in the spring, if you were looking at my section, they finally fixed the fact that Thursday was listed as lab and Thursday was listed as lecture, which obviously doesn't work when we're Zooming lecture, but kind of sort of meeting for lab. They finally fixed that. The night lab is now on Wednesday night with lecture maintaining the Tuesday, Thursday schedule. Just if there's anybody who's interested in that. I got notification from the guy who does all the scheduling going, we fixed it. Because I had sent them email going, I can't do this. This is wrong. Can't be in 2 places at the same time. So gather up whatever your remaining questions are for Thursday. We'll talk a little bit more about the test again on Thursday, and then you'll have all weekend to do the test. As I madly grade papers. Well, not literal papers, digital papers. All right, I will see you on Thursday.